All right, so let's pick up with number 12. So number 12 says two numbers have a sum of 53 and the first number is 5 more than the second. What are the two numbers? So remember, you want to start at the end. What are the two numbers? That's what you're trying to find. So I'm going to say, okay, I'm looking for my first number and my second number. All right, then it says the first number is, remember, is means equals, 5 more than, so plus the second. So the first number equals 5 plus the second. So first number equals 5 plus the second. I'm going to call the second number x so that I can say the first number is 5 plus x. Okay, so then it says two numbers have a sum of 53. So I'm going to take the first number, 5 plus x, and the second number, x, and I'm going to find their sum, and that sum is 53. So that's going to give me 2x plus 5 is equal to 53. To get x by itself, subtract the 5 from both sides. So 53 minus 5 left me with 48. And then to get x by itself, we're going to divide both sides by 2. So x is equal to 24. Now, remember that you're also going to stop at the end. So go back and look and see what are the two numbers. Make sure you answer the question that was asked. You don't want to just give the 24 and lose points because you just forgot to find the second number. All right, so we just figured out the first number is 24. So, I'm sorry, we just figured out that one of our numbers was 24. So now we can come over here and say, okay, well, the other number is 5 more than what I just found. So 5 more than 24 would give me 29. So my two numbers are 24 and 29. Then check to see if that makes sense. Like if I add 24 and 29, I do get 53, and one number is 5 more than another. So I feel pretty good about that. All right, then for number 13, it says the length of a cell phone is twice the width and the perimeter is 24 inches. So what are the dimensions of the phone? All right, so I'm going to draw myself a little picture here. Again, start at the end. What are the dimensions of the phone? So I'm going to look for the length and the width. Okay, so it says the length is twice the width. Length is means equals twice the width. So I'm going to say my width is W and my length is 2W. So I'm going to come over here and draw myself a little picture. So the length is 2W and the width is W. And then it says the perimeter is 24. So remember, the perimeter is the sum of the sides. So I can say 2W plus W plus 2W plus W. That would be the sum of all my sides is equal to 24. So if I add these, 2W and 1W is 3W, plus 2W is 5W, plus 1 is 6W. So to get W by itself, let's divide both sides by 6, and we'll have W equals 4. All right, so again, start at the end and stop at the end. What are the dimensions of the phone? We found the width, but we still have to find the length. So if the length is 2 times the width, then I can say, okay, length is 2 times width. That means it's 2 times 4. So my dimensions would be a length of 8 inches and a width of 4 inches. All right, then we moved into our imaginary numbers, and we want to be able to add, subtract, multiply, and divide them. So first off, when adding, we can go ahead and drop our parentheses here because that addition sign, if we distribute a positive 1 through, it's not going to change anything. So now we're just combining like terms. So remember that I is not a variable. It represents the square root of -1, but it combines just like a variable would. If you had a positive 3x and a negative 3x, they would drop each out. If you have a positive 3i and a negative 3i, they're going to drop each other out. So that leaves me with 2 plus 3, which is just 5 for my answer. Now, if you're unsure where we got this 3i right here, remember square root of -9, we can say that that's just 9 times square root of -1. So square root of 9 is 3 and square root of -1 is I. So for right here where we have the square root of -9, that's where we got 3i, and same thing right here, that's where we're getting this 3i. All right, so when we're subtracting, remember that your subtraction sign is going to change everything that comes after it. So we're going to distribute a -1. So that's going to give us a -3 and a positive 3i. So again, when I combine like terms, 2 minus 3 would give me -1. And then 3i plus 3i is going to give me 6i. Now, notice that it says give answers in standard form. Standard form is A plus BI. So that's how I want to write that, not 6i minus 1 or something like that. All right, then I'm multiplying. I'm going to FOIL. So I'm going to say 2 times negative 1 is negative 2. 2 times negative 4i is negative 8i. 3i times negative 1 is negative 3i. 3i times negative 4i, well, let's do positive 3 times negative 4 is negative 12. And I times I is I squared. All right, so negative 8i and negative 3i would be negative 11i. Remember, I squared is the same thing as negative 1. So we can say negative 12 times negative 1 is positive 12. So then I could combine 12 and negative 2 to get 10. And again, I'm going to write this in A plus BI standard form. All right, when we have a radical in our denominator, we're going, and it's being added or subtracted to something else, we're going to multiply by its conjugate. So the conjugate is the exact same numbers, 1 and 2i, just the opposite sign in between. So that's called our complex conjugate. And what I do to the bottom, I have to do the same thing to the top. So up here in my numerator, I'm just going to say I've got 3 times 1 minus 2i. And then down here in my denominator, I'm going to FOIL just like we did over here a second ago. So I'm going to say 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is positive 2i. And then positive 2 times negative 2 is negative 4. I times I is I squared. So the positive 2i and negative 2i cancel each other out. And I squared is negative 1, so that's going to leave me with 1 minus 4 times negative 1, like you see right here. So negative 4 times negative 1 is positive 4, so we're going to have 1 plus 4, or 5, in our denominator. Now, I waited to distribute in my numerator up here because, for instance, if I had gotten 3 down here, I would have been able to cancel that 3 top and bottom. But since there's nothing that will cancel or simplify now, I'm going to go ahead and distribute. So 3 times 1 gives me 3, and 3 times negative 2i gives me negative 6i. Don't forget you're supposed to write your answer in standard form. So that's A plus BI. So we need to break this apart. So this is 3 over 5 minus 6 over 5 times I. So 3 over 5 minus 6 over 5 times I, A plus BI. All right, on this next set of problems, 15, 16, 17, and 18, where you're solving a quadratic by 4 different methods, you'll be allowed to eliminate any one of those problems. So you can choose any 3 of the 4 to do, and you can omit the 4th one. All right, so solving a quadratic by factoring. All right, so remember that I'm going to find the factors of 20. So that's what we did right here. Because this is a subtraction sign, remember that we're going to say difference. So I'm going to find the difference between my factors. And then I'm looking for the 2 and the 10 to give me that 8. And then remember, different reminds me my signs are going to be different, one positive, one negative. And the larger one has to have the same sign as that middle term. So I would need a negative 10 and a positive 2 to add up to be a negative 8. So once I have it factored, I can just set each of these factors equal to 0. And then here I'm going to add 10 to both sides, and here I'm going to subtract 2 from both sides. And those would be my 2 solutions. All right, if I'm solving by the square root method, I want to try and get x squared on one side by itself and everything else on the other side. So to begin with, I'm going to add this 12 over to the other side. So that's what you can see right here. We have x squared equals a positive 12. All right, then to get rid of the square, we're going to use its inverse, square root. And when I insert a square root, I always put in a plus or minus with it. So the square root of x squared just left me with x. And now I have plus or minus the square root of 12. Now, since this will simplify down further, I need to. If it wouldn't, then that would be my answer. But 12 prime factors down to 2 times 6, and 6 is 2 times 3. So I have a pair of 2's right here. So if you have a pair, you can take it out from under the square, and then I have a 3 left over that's going to have to stay underneath. So that would be my solution. X is equal to plus or minus 2 square roots of 3. All right, then if I want to solve by completing the square, so to solve by completing the square, step number 1, I'm going to move my constant to the other side. So I'm going to take this negative 19, I'm going to add it over to the other side. And so now I'm ready to complete the square. So to do that, I take the coefficient of the middle term, my b term. So coefficient of the middle term, -8, I'm going to cut that in half and square it and add it to both sides. So -8 cut in half would be -4. And then I'm going to square that and get 16. And that's what I'm going to add to both sides. All right, so now I'm going to factor this left-hand side. So x squared would be x times x. And what multiplies to be 16 and adds to be -8 would be a -4 and a -4. Remember, when you've completed the perfect square, you're going to get the same factor here as you do here. Also, so x minus 4 times x minus 4 would give us x minus 4 squared. Also, remember that little shortcut we said that whatever this number is before you square it is always going to end up being what's here in your factor. Okay, so now I can go ahead and solve by the square root method like we were doing in our last problem. If I want to get rid of the square, I'm just going to insert a square root on both sides. Don't forget your plus or minus. And now I can add 4 to both sides, and so I'm going to have 4 plus or minus the square root of 35. All right, then for number 18, we are solving the quadratic by the quadratic formula this time. Okay, super important that you always set your quadratic equal to 0 when you're going to use the quadratic formula. So I'm going to subtract this 6 over to the other side. So then it's ax squared plus bx plus c. So a is going to be 3, b is going to be -1, and c is going to be -6. So once we've defined those, then we can use our quadratic formula. So -b plus or minus the square root of b squared minus 4ac over 2a. So we're going to do -b, b was -1, plus or minus the square root of b was -1 squared minus 4 times a was 3, c was -6, all over 2 times a was 3. All right, so if we simplify, remember under here you have to do order of operations. So I can't do -1 squared is 1 minus 4 is -3 and keep going from there. I have to do -1 squared is +1, but then I need to do my -4 times 3 times -6 to get my +72 before I combine them. All right, so then 1 and 72 is going to give me 73. And of course, back here we had minus and negative, so that's going to be +1. So we've got 1 plus or minus the square root of 73. And then in our denominator, we had 2 times 3, so that's our 6. All right, then the last thing that we want to look at here is the discriminant. So remember, the discriminant will tell you what kind of roots that you're going to have and how many of them you're going to have. So if your discriminant is greater than 0, then you're going to get 2 real roots. If your discriminant is equal to 0, you're going to get 1 real root. And if your discriminant is less than 0, you're going to get 2 imaginary roots. So the discriminant is just b squared minus 4ac. So again, I'm going to identify a, b, and c. So a is 1, b is -6, c is -2. And so then we can just plug in and say b is -6, so -6 squared minus 4 times a was 1, c was -2. And so that's going to give us, again, following order of operations, -6 squared would be 36. And then I have to multiply the -4, 1, and -2 before I combine that with the 36. So -4 times 1 times -2 is +8. So 36 and 8 is 44. So my discriminant is positive. Since my discriminant is positive, then that means that I'm going to get 2 real roots.